Okay, discontinuity of functions. Recall a function f is said to be continuous at a point x equals a, where of course a is a member of the domain in the function f, if the following is satisfied. If one, we want f of a exists. Number two, we want limit as x tends to a, f of x exists. And then number three, we want limit as x tends to a, f at x to be equal to f at a. If these three conditions are satisfied, we say that a function is continuous at the point a. So we emphasized last time in the previous videos that if any of these three conditions breaks down, we say that the function is a discontinuous function. Alright, today our interest is, or in this video our interest is to distinguish between types of discontinuity. Because if you observe here, they have three conditions, so there's possibility of three different things happening. Number one is that it's possible that f at a does not exist, and then it's possible the limit does not exist. It's also possible that the limit exists, f of a exists, but they are not equal. In each of these possibilities, we have different names for them. And so that brings us to what we call types of discontinuity. Okay, types of discontinuity. Number one, we're going to discuss removable discontinuity. Removable discontinuity. Okay? A function f is said to have removable discontinuity at x equal a if the limit as x tends to a of f of x exists, but f of a does not exist. So if the limit as x tends to a exists, but f at a does not exist, we say that such a function has removable discontinuity at the point x equal to a. Example, if we take f of x to be equal to x squared minus 1 divided by x minus 1, then at x equal 1, we want to see whether this has a removable discontinuity or not. First, observe that at x equal 1, f of 1 is 1 squared minus 1 over 1 minus 1, which is 0 over 0. This is indeterminate, which means f of a does not exist. And then from a definition of discontinuity we have, that suggests immediately that the function is discontinuous at the point x equal 1. So the next thing to do is to check if this discontinuity is removable. And so what we have to do is to see if we can get, if the limit as x tends to a exists. Our a in this case is 1. If that limit exists, then already we have seen that f at a does not exist. By definition, it means that the type of discontinuity we have for this function is a removable discontinuity. Alright. Our f at x, like we know, is x to the 2 minus 1 over x minus 1, which we can rewrite as x minus 1 multiplied by x plus 1, difference of two squares, divided by x minus 1. And then here, x minus 1 will divide x minus 1 to give us 1. So everything now reduces to x plus 1. So we can rewrite f at x as x plus 1. So here now we know that as x tends to 1, f at x will tend to 1 plus 1, which is 2. So limit as x tends to 1 of f of x is precisely 2. So this limit exists. Already we have seen that f at 1 does not exist, so it means the function is discontinuous at x equal 1, but because we can compute this limit, we see that it is a removable discontinuity. So this is an example of a function that has removable discontinuity.